So originally, when we decided to show gravity, I was going to give a physics talk about gravity, but then I've decided that not to. And so for those of you who want the physics talk about gravity, we could probably meet in the bar after the movie. But for now, I thought I would talk a little bit about gravity, and then more about what it's like without gravity, because that seems to be a kind of unique experience, and what things that people are interested in. And if you find we only have about 25 minutes or so, so I'm going to go pretty quick. But if you find you have something some burning question you just have to ask, just shout it out, and I'll do the best. Otherwise, we'll have a couple minutes at the end, I think, for questions. So, what's gravity? It's very simple. It's just the mutual attraction of anything. Any two things attract each other. That's what Einstein said, and it's what Newton said. What Einstein really said was that gravity is the mutual attraction of two things because everything warps space a little bit, and things tend to roll downhill towards each other due to the warping of space-time. It's one of four forces of nature that we know about. There's gravity, there's electromagnetism. Those are the two that we're familiar with. And then there's two forces that act way inside the nucleus of atoms. They're called the weak force and the strong force. And now you know almost as much about them as I do. Actually, not quite. But the interesting thing about gravity is that it is the least of the well-experimented forces because it's so weak. If you take two protons are both positively charged, and hold them next to each other, because they're positively charged, there'll be a repulsive force between them. So the electrostatic force of the charges will try and push the protons apart. But since the protons also have mass, there's the gravitational force pulling them together. And the ratio of those two forces, the electrostatic force pushing them apart and the gravitational force pulling them together, is this number up here. That's a 1 with 32 zeros. So that's how much stronger electricity is than gravity. That's the reason that generally in our experience, we don't see electric charges, because all the plus and minus charges pull themselves together. And it's the reason that, and gravity is so weak, is the reason we can actually jump off the floor against the pull of the entire planet with trying to pull us down. So it's an amazingly weak force, but it's the force that we interact with most of all. And one good example of that is that rockets use chemistry. The engines on rockets nowadays are based on chemistry, and chemistry is just electricity. Chemists love to hear that. And so, but even on 5 little rockets, on the 5 actually big rockets, but small compared to the Earth, on the Space Shuttle, using the power of chemistry, are able to lift 7 million pounds off the Earth straight up into space, and which is just a remarkable thing. Okay, and so human beings evolved to be 1G organisms. Had we lived someplace else, we lived on the moon, if instead of weighing, say, 180 pounds on the Earth, if you were on the moon, you'd weigh 30 pounds. You'd feel like you weighed 30 pounds. If you lived on Mars, you'd feel like you weighed 60 pounds. So our bodies are uniquely evolved to live in this environment of, we call it 1G. That's 1 times the force of the Earth pulling down on us, and that's has shaped our whole evolution. We are 1G creatures, and so it's affected our bodies, our physiology, our activities, our size, our shape, the way we move around. It was all evolved in this 1G environment. Had we evolved on a planet with a sixth of a G, we'd probably be a lot taller and spindlier and smarter. I don't know. Okay. So when you're in space, you're in zero gravity. So what is zero gravity? Actually, Einstein pointed out, he has this principle of equivalency, that you can't tell the difference between being in a box and falling towards some object or being in the middle of deep space inside a box. Either way, you're going to be floating inside the box, and we call that zero gravity. When you're in the space shuttle, you're not very far above the Earth, 200 or 300 miles, but you're going sideways so fast, 17,500 miles an hour, that as you fall towards the Earth, because the Earth is pulling down on you with almost the same force of gravity as you have when you're standing on the surface, but as the Earth pulls you down and the spaceship curves towards the Earth, it's going just fast enough so that it matches the curvature of the Earth. And so you're continuously falling around the world. That's what being in orbit means, and that's just like the picture on the right there. You're falling, you feel like there's no gravity, even though there is, but you're going sideways really fast. But Einstein would tell you, inside a box, like being inside the cabin of the space shuttle, you can't tell the difference.
Can we ask questions?
I bet you can.
When you're in orbit, aren't you slightly reducing the distance of the Earth to
No. Well, depends on how high in orbit. When you're in a low Earth orbit, like the space shuttle, there's a tiny, tiny, tiny bit of drag because there's extra air molecules up there. It's not because of physics. I mean, not orbital physics. It's because there's some drag. Okay. So first, let me talk about physiology. So the big picture: what does zero gravity do to your body, and what do we do to interact with it? So basically, we use diet, exercise, and drugs. Things that happen to you in zero gravity. When you first get into space, when you're launching, you're feeling 3 Gs, so you're pushed back in your seat with 3 times the force of gravity. When you get into space, the engine's cut off, you start to fall, you're in zero gravity. And the first thing that happens is your legs are still squeezing like they do here on the ground to keep all the fluid. You know, human beings are basically just waterproof bags full of liquid. And the fluid tends to go down, and you have skin that squeezes and muscles that squeeze and hearts that pump. And so as soon as the engine's cut off, you can just feel all this fluid come right into your head. And so you get a headache. You look at your partner next to you, and their face is all puffy, and you look weird, and you feel weird. And so your body needs less fluid in zero gravity. And so over the course of the first 24 hours or so, you line up at the toilet and you pee. And you go from the front of the line to the back of the line. And after about 24 hours, you've gotten rid of about a fifth, 20% of your blood volume. You still have as many red blood cells, but you just have a quart less liquid in your blood, and with that, then the swelling in your face goes down, your headache starts to go away, and you feel a little better. The other thing that happens is your only true input about what your orientation is your eyes, because your feet aren't connected to the floor. The liquid fluid in your inner ear is weightless. It's floating around. So your brain is getting all these conflicting inputs about what your orientation is. And the typical response of the human body in situations where weird things are going on is to shut down your gut. And so during the first 24 hours in space, it used to be about half the people threw up, and the other half felt like throwing up. But now they've told me in the last few years, with research they've been doing on the space station, they use a drug called phenergan, which is a fairly common drug, I guess, and that seems to have overcome the space motion sickness part of it. So they're not having so much trouble with that. Other thing that happens in space is you grow. I was almost 6 feet tall when I was in space, because your back unloads and all the ligaments in your back stretch out, and you actually get a backache for a few days too. So you take Tylenol, and that makes you feel better. Your heart doesn't have to pump uphill. So over the space of a few days, even your heart shrinks. You lose muscle mass in your heart. Your legs aren't holding you up. Your muscles, your arms aren't holding you up. Your neck's not holding your head up. And so the muscles in your body also start to degenerate. You lose muscle mass fairly quickly. Your bones aren't being stressed, so you lose calcium out of your bones. Excuse me. At some reasonable rate. And but all of those can be overcome. When you come back down to the ground, your bones grow back. Takes a couple of years. Although now on the space station they have an exercise routine. You can see this guy working out here, and they've got the exercise down. They've got the diet down, where the people who are going to spend a long time on the space station are actually coming back in better shape than when they left. Their bones are better. Their heart's better. So they seem to have solved that, along with some drugs that I don't know and probably wouldn't take. When I was flying in the early shuttle program, one of the things they did before your flight is they gave you a bag of drugs, all the drugs that were in the kit, the medical kit on board. And they said, try these out, see if you have any adverse reactions to these drugs. So I kept my toilet from throwing up, and I put my toilet to sleep, and because I wasn't going to take any of these drugs anyway, so I just flushed them. And I was the medical officer on all three of my space flights, and basically told the rest of the crew that this is the locker that's got all the drugs in it, and I got the key, and you're out of luck.
Question, does the potency of any of the drugs change?
Yes. Yeah, the potency changes, the metabolism changes. They don't quite understand it, but they've done experiments. And we did one on one of my flights. We called it sucking cotton. We just took Tylenol, I think it was, and then it goes into your saliva, and so you suck on saliva every half hour or so, and you can see how the drug metabolized. And it's different than it is on Earth. Yeah. Some and not predictable. Some higher metabolism, some lower metabolism. Another really interesting thing that's happened, they've discovered with people long-term in space, is that it affects your fluid balance is all screwed up, like I said, and your optic nerve swells up, especially for older guys who, like me, who have to wear reading glasses, and your optic nerve swells up, and it actually presses against the back of your eye, and it ripples the retina, and so their vision just goes completely to hell. And unfortunately, the people who have had it don't recover completely. So it's a real hazard, and they're still working on that one. It doesn't happen to everybody. It seems to happen to men more than women. They don't know why, but they're working on that. So the progress they've made, since in the many years since I've flown, through diet, exercise, and drugs is really, really pretty pronounced now. They've decided it's for a year and a half or so trip to Mars that we're ready to do that. And one of the ways they learn that is by with these two guys who are real heroes, not because they're astronauts necessarily, but because the science experiment they did, they're identical twins, Scott and Mark Kelly. And Mark's actually running from Arizona, so if any of you are snowbirds and vote in Arizona, he's running for the Senate. Vote for him. He's Gabby Gifford's husband. And but his brother Scott spent 340 days in space, and they did it as an experiment. Both took blood samples, and all went through the same kind of tests and that, and really, it's an N of one, but still we learned a lot by watching these two. And one of the things we learned is that the expression of their DNA, the way their genome actually worked, changed while Scott was in space. His genes were working differently than Mark's were on the ground, but it only took about 48 hours after Scott came back before his body had readjusted. His immune system also changed while he was in space, and I guess it happened to all of us. His immune system just went on high alert. I don't know what that means biologically, but it was ready to fight off anything. It was like it had been invaded. His body had been invaded by a foreign substance or something, and so it stayed on high alert all through his mission. And he came back down. It took some months before his immune system calmed down again. So that's another issue that they really don't understand yet. And he still, after 3 years, still has a little bit, but it's calming down. But two guys, funny-looking guys, but they're both good. They're Navy pilot, both Navy pilot, and identical twins. It's just amazing. They have exactly the same careers, pretty much, and that's understandable, I guess. So that's the big picture of physiology. So here's what's it like to live in space? Well, it's really fun. That's about all I need to say. And the part you're not going to see that makes it really fun is looking out the window, just watching the Earth go by at 5 miles a second over the ground, and you're really going fast. It takes 90 minutes to go around the planet, and the Earth's gorgeous. But zero gravity is also really fun. It's fun to do all of these events. So here's just I'm just opening a bag of M&Ms and letting them come out of the bag. I don't know why I have both an apple and a bag of M&Ms. But and you can tell it's early in the mission because we flew just a small amount of fresh food, carrots and apples, and they were gone by the second day. So this must be fairly early into the mission. Okay, so here's what it's like to eat in space. And the one thing that comes by fairly quickly, there's a scene where I'm drinking coffee. And so just to let you know that it's coffee. That's all you need to know. I'm making breakfast. This is a galley. We don't have a stove or anything. We can't cook. We can just warm things up. Not even like a microwave, just like a toaster oven or something, but it doesn't cook. And scrambled eggs are fun. And it's kind of every mother's nightmare, except you can't spill things on the floor, right? You let something go, it doesn't fall anywhere. And over you can see there's a drink container, and the little straw has a valve on it so that the fluid doesn't get out, because if you let the fluid out. So this is the coffee. And yeah, kind of just like I do at home here. And there's bananas. And when we first made that, we got the giggles, and we just couldn't stop. The commander thought we were nuts. Okay, so zero gravity is really fun. Sleeping's a little different. This is on my first flight because I didn't sleep in the sleeping bag on my subsequent missions. And you can see I have a little strap over my head that's holding my head down, like makes it feel like you're lying on a pillow, because when you're just stretched out in the cabin, there's no up or down, so you don't feel like you're lying on a bed. Rolling over doesn't make any difference. And I have these little dark glasses on because at the speed we're going, you go around the world every hour and a half. So every hour and a half, the sun comes up and the sun goes down. So in 24 hours, you see 16 sunrises. And so you got to keep your eyes covered if you want to keep the sun out of your eyes. And everybody tucks their arms in like that because when you fall asleep, your body goes to its natural position, the natural position of the human body. And you can try this yourselves. If you go to a swimming pool, just hold your breath and relax in the water and just let yourself completely relax and see what shape your body assumes. And it's like this. And so when you fall asleep, you have your arms tucked in, but you can tell when someone's actually falling asleep, their arms come out and they go, and there you can see a couple of guys in their sleeping bags. And this isn't communicating with the ground or anything. That's listening to music. One of the things that happened to me on my first flight, because we were a fairly high altitude, one sleep period I was sleeping, and I got woken up by flashes in my eyes. And I didn't know what they were. Sometimes they were streaks of light, and sometimes they were like expanding circles. And I thought, whoa, this is really weird. And I thought, well, I'll bet you it's cosmic rays, and why didn't they tell me about this ahead of time? And so I went back down. When we got back down to Earth, I asked, cosmic rays. And they said, oh, yeah, we should have told you about that. So when you're above the Earth's atmosphere, you get higher energy cosmic rays. They're still secondary because they hit the cabin walls, but they're higher energy. And when they hit your retina and it's dark, then they make a flash, which I thought was really cool. So working inside the cabin, I always tell people one of the cool things about it being a scientist astronaut is I got to do all kinds of really neat science experiments in material science and chemistry and physics. But sometimes when you're doing biology, sometimes you are the experiment, and that makes it kind of fun. This is John Glenn, who flew when he was 77 years old or something like that. He had been, a powerful senator for a long time and finally talked NASA into letting him fly, which I thought was a wonderful thing. He'd flown once, done 3 orbits in a tiny little can that didn't have a window, and had no idea what it was like to be in space. So when he got to fly on the space, and he had to tell America about what it was like to be in space for 50 years. And so when he finally got to fly, I thought it was really cool, well deserved, and he did perform just spectacularly. He flew as an experiment. His experiment was old guy in space, and he did just great.
Did you get the retinal thing?
Pardon? No, he didn't. His vision wasn't affected. But he was on the space shuttle for a flight of a couple of weeks, so he wasn't. It's the people who are on the space station for months that have the eye problems. So working outside is a little different. And my first flight, I was lucky enough to get to go out. This is me and Jim Van Hoften out fixing a satellite. And the different thing about being outside is that you have to take everything you need with you because there's no air out there. And so you have to take your own oxygen and your own battery and radio. And unfortunately, there's no food in there. So on this spacewalk, we were outside for almost 8 hours, and you get really dry, and because you're in the spacesuit is pure oxygen atmosphere at a fairly low pressure, and the suit. This is where you're happy to be in 0G because the spacesuit on the ground weighs 190 pounds, and so it would be a real pain to have to carry it, which I've had actually done, walking in and out of vacuum chambers, walking with this 190-pound suit on, and it's no fun. My collarbones actually still have little chips in them from holding up the suit.
When you were trying to capture solar max with the Stinger, what was wrong with the Stinger? Because they had to eventually use the arm to bring the solar max into the cargo bay.
Oh, you know too much. I'll tell you in a minute, okay? Yeah, you're kind of mixing up 2 missions. We didn't use a Stinger. We used something else. I can't even remember what it was called. Okay, so as far as communicating in space, when you're inside the cabin of the space shuttle, it's just like being in this room. Sea level, air pressure, your ears don't pop when you take off because the pressure in the cabin doesn't change. Sound travels through pressurized air, not through a vacuum like radio does. So if you're inside the cabin, talking, listening is perfectly normal. Outside, you need a radio because you really can't yell through a vacuum. What have I missed here? One thing I didn't tell you about eating, which is I showed the pictures of eating, but eating is really interesting. Eating once you get the food in your mouth is not much different than here on the ground. Gravity doesn't pull food down to your stomach. So swallowing and chewing and swallowing feels just like it does here on the ground, except for liquids. Liquids kind of, instead of sitting down in your mouth, kind of cling to all the surfaces. So when you take a drink, the water just kind of fills up your whole mouth, kind of, and feels really weird. Once the food gets in your stomach, it's kind of a unique experience because it's weightless in your stomach too. So if you move, the food goes doing blub, 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 blub. And you can feel it kind of sloshing around in there, and it's not uncomfortable or anything like that. It's just weird, and you get used to it after a while. Okay. So the one question people always ask, and it's interesting because when you give a talk like this, whether you're talking to a group of aerospace engineers or a kindergarten class, you get the same questions because it's such a unique experience. Well, this is the toilet in the space shuttle, and you can see these two bars. This is the seat belt here to hold you down. This is the little urine collector here, and it's not so much a toilet as it is a vacuum cleaner. That's how it works. So it just runs airflow. So you pee in the tube and it goes, and it sucks it into a tank. And when the tank gets full, we dump it overboard, which is really beautiful. It sprays out this nozzle and turns ice crystals and you get this nice. No, I had somewhere, but not here. And when you poop, I guess you have to hold yourself down on the seat, and you have to. It's a cylinder about this big around, so you have to aim well. And there's the most disgusting trainer in the world with a camera that looks up the tube. Nobody uses it more than once. There are things you just don't need to know, and then the feces is taken down into a container, and then when you turn the toilet off, it's fairly noisy, and you turn it off, it actually freeze dries everything. Okay, perfect. Okay, spoiler alert for the movie. If you've seen Gravity before, if you haven't, it starts out with George Clooney flying around in space and using something called the Man Maneuvering Unit. And there are only six people who have ever flown the Man Maneuvering Unit. And so there's been some discussion about who's the role model for George Clooney, when I know it's me. Because, well, I know the other guys. So I want to show you what it really looks like to fly in the Man Maneuvering Unit. And so this is a satellite out about 100 yards away from the space shuttle, and this is me in the payload bay with no tethers or anything. I'm just out there in my own little spaceship, and the little Man Maneuvering Unit on my back has compressed nitrogen tanks and little jets. The black dots you can see are little nozzles where you can spritz gas out and propel yourself really slowly. Unlike the movie where he's just going all over the place in this thing, you are extremely low on fuel when you start. So you've got to be really careful. And the only instrumentation on it are two little button gauges up by on the towers up next to you up here, and they look like gauges on a fire extinguisher. You know, they're green, yellow, red, and so I flew over about 100 yards over from the space shuttle to the satellite at the scorching speed of 17,500 miles an hour plus a half a foot per second. Actually, minus a half a foot per second because I was going backwards. And my role in this mission, the satellite had failed and it was slowly tumbling, was to attach myself with a device to a pin about the size, about an inch in diameter and about 4 inches long that was sticking out the side of the satellite, a trunnion pin. And we had a device that had that when you went around that pin, clamped jaws down on it. And it turned out that the satellite had a thermal blanket on it, and the blanket was put on with little standoff pins. And it turns out they put one of those standoff pins right in the wrong place, so that we went up to dock with this thing. You can see what happens. I go into dock, and I hit that pin, and I didn't penetrate far enough to fire the jaws on the docking device, so I just bounced away. And I weigh 700 pounds or so with all that gear on. And the satellite weighed about 4,000 pounds, and so not too different. So when I banged into the satellite, it started tumbling one way, and I bounced off the other way. And we wrestled for a while and figured the docking device wasn't going to work. And so Bob Crippen, the commander, asked me if I would try grabbing hold of the solar rays and seeing if I could stop the satellite that way. So I grabbed on the solar rays are made of glass and they have sharp edges, and so I grabbed hold of the solar rays and worked my way out, and I actually took most of the energy out of the satellite at that point, but it was still tumbling a little bit. And then I made a dumb physics mistake. I had the satellite almost stopped, and then I let go, and the center of gravity, for those of you who know what that is, jumped in the satellite, and it started tumbling again. So we failed to get it that day, and luckily the ground was able to stop the satellite from tumbling using the Earth's magnetic field, and then we rendezvoused with it and captured it the next day. But so this is there I go. Luckily, I was deeply in the yellow when I got back to the space shuttle. I'd used a lot of gas doing this, so that was my George Clooney impression, or you might turn it the other way around, that George is doing his George Nelson impression when he in the film. So that's it. Thank you. How long do we have? 1 minute? Got a question or two? Go ahead.
How accurate do you think this film is to your experience?
Not very.
So, it talks about Mars being 1/6 of the gravity of
A third, yeah.
A third, thank you. And people talk about going to Mars and the possibility of going to Mars. How can the human body be part of that and be at Mars that long and evolve at Mars and come back? Can they think they can do that? You think that the human body can go to Mars, be there for as long as they need to be for a year or 6 months, come back?
Oh, sure.
You think so?
Yeah, and your body won't change much while you're on Mars, I suspect. And the real danger of going to Mars is the trip, well, actually being on the surface, going there, being on the surface and coming back. The real danger is cosmic rays. The Earth is shielded by its magnetic field, shields the high energy cosmic rays. Mars doesn't have a magnetic field, and so cosmic rays penetrate right through the atmosphere. And in the spaceship going to Mars, 6 to 9 months each way, you're going to get pretty high cosmic ray exposure.
So would you go if you had a chance to go if you were younger? Would you go to Mars?
Older?
Or older, yeah. Maybe. Susie and I have to discuss this, right? I always say I might go if I could be the first one. I don't know if I'd want to be the second one, but that's kind of a selfish answer. Yeah. Okay. That's it?
No, there's more.
Oh, okay.
Yeah, what was the rescue procedure if you needed help when you were on there?
Oh, okay. So if you're flying the maneuvering unit has 2 redundant systems. So if one system fails, you can switch over to the other system, so you have a backup. And if everything fails, then the space shuttle could fly over and get you. So I didn't have any worries about that at all, actually.
So you wouldn't spin out of control and just go away into oblivion?
Well, that's why you train, right? Yeah, right. Yeah, exactly. I had many hours in a actually 6 degree of freedom, which means it was just like being in space, kind of, only and you're back at this big machine behind you up in Denver. They have an apparatus that they adapted to do the training on. They had a mock-up of the satellite and a mock-up of me, and I did lots of practice rendezvous, and they would put failures in. You'd get like within 6 inches of the satellite, and they would fail all 4 jets pushing you at the satellite, and you had to react and figure out which system had failed and throw the right switches. And so you do that over and over again until your brain isn't involved anymore. You see something and it goes right to your hands, and you do the right thing. Sometimes you end up upside down. Okay.
One more quick question.
Okay.
Are you involved at all with NASA? Because you have so much expertise, do they still ask opinions or whatevers from you?
Not really. I actually chaired a committee that did an external review of the Space Telescope servicing missions, because they were very similar to this. But I haven't been really involved in with NASA for quite a while. So there's a lot of expertise at NASA, a lot of smart people. All right.
Thank you.
You're welcome.